Uh, welcome back. Welcome back. Let's continue as we explore the chemistry 120 from natural sciences. Yeah, yes, again, Elastinkala, please try to subscribe, try to comment, try to like for more videos. Yes, so we are trying to identify acid, bases, conjugate acid, conjugate bases. Yeah, so for this question is saying to say, water react with hydrochloric acid. Yeah, I'm on the question number 2. Water reacts with hydrochloric acid to produce hydronium and also hydrogen carbonate. You have to identify using Arrhenius equation, Brother-Solas theory, or sometimes Arrhenius equation to identify which one is a conjugate acid, which one is a base, which one is acid, which one is a conjugate what? A conjugate base. So if you see very much properly, even also grade 12 you can identify a base and acid, but most of challenges comes in, even most of students face challenges when it comes to identify which one is a conjugate base, which one is a conjugate acid. As you see, we've got H2O. Water is neutral, it has got a pH of 7, it can be either a base or acid. And also I've got the carboxylic acid. So the word itself, acid. So carboxylic acid is a base. So this, it can only take place if I've got one acid, which means I have to take place also. If I've got acid, also which means I have to have what? A base. It's more like a neutralization reaction. A base and acid. So if I've got an acid, so if I've got an acid, in other hand I have to have what? A base. So water, for it to be neutral, if carboxylic acid is an acid, then water is a what? It's a base. Now, most of challenges comes in to identify which one is a conjugate base, which one is a conjugate acid. So, if I've got H3O plus, H3O plus is being formed, that is hydronium. Some books they put only hydrogen because symbolized to say this is an acid. They use Arrhenius theory. Any substance dissociate in water to produce hydrogen ion as a positive charge or hydronium ion as the positive charge. Now, if you see very much properly, again, if you use, I'm talking about a reactant here, if you use Brother-Solas theory, an acid is a proton donor. An acid is a proton donor. So it's going to donate an electron. What I mean here is this. What I mean here is this. An acid, it's a proton donor. So what will happen here is this. For it to be a proton donor, we want to say water here, it's a base. Right? I'm using symbols here for the sake of time. Carboxylic acid, from the word carboxylic acid, it's an acid. Right? You cannot have two acids or two bases, you just have to have one acid and a base. So here it's a spontaneous reaction or dynamic reaction, dynamic equilibrium reaction or reversal reaction. So what will happen? According to Brother's theory, an acid is a proton donor. So it's going to donate an electron to a base. And the base will receive that electron and occupy a what? You receive that hydrogen. So what it has, we've got H2 there. We've got H2 there, H2O, of which I've got 2 hydrogen in water. So this acid is going to donate 1 electron to water. And water will increase hydrogen from 2 to what? To 3. Right? We increase each electron or each hydrogen from 2 to what? To 3. Right? And maintain its oxygen. When it comes to acid and bases, we'll talk about only sharing of hydrogen ions, that's so, or hydrogen atoms, that's so. So, carboxylic acid donate an hydrogen to water, hence will be having H3O plus. So for it to donate an electron to water, water becomes a conjugate acid. Because it has received an electron. That's why to say a conjugate base, a conjugate acid, it is an acid or substance that has formed after receiving an electron from an acid and occupy a positive charge. So this one to be a conjugate what? A conjugate base. Hydronium to be a conjugate what? A conjugate base. So I put CB here, which means a conjugate base. What about this one? HCO plus, which is hydrogen carbonate. This one, see what's going to happen here. After an hydrogen here, or carboxylic acid, donate an electron to water. One electron. Water will increase hydrogen from 2 to 3. Then carboxylic acid will reduce an hydrogen because it has given out. It will reduce it from 2 to what? To 1 and occupy a negative. So a conjugate base, it is a base or it is a substance that formed after giving out an electron or an hydrogen, or it is any substance that's formed after acid or an acid given out an electron to a base and occupy a negative what? Charge. That's a conjugate what? A conjugate base. So CHO3 negative, it's a conjugate base. Okay. We go to the next question. We've got C5H5NH plus H2O, which is water, undergoes spontaneous, which is a dynamic equilibrium equation or reverse reaction, producing C5H5N plus hydronium. You know, something that it is something that is really much easy here. Right? If you see hydronium, that is going to say hydronium CH3, that is a conjugate acid. That's all. If I've got a conjugate acid, this side you have what? A conjugate base. Then this side, if I've got if I've got a conjugate base, this side I've got a conjugate acid. If I've got a base with this side we should have what? A conjugate what? If I've got a base, this side we should have what? An acid. Something like that. So what will happen here, you see, we've got 4 substances here or compounds. I've got CH5NH plus, also I've got H2O, which is water, and also I've got C5H5N, and also I've got hydronium here. You know, some of these things, if you just know them, you said to say hydronium that is always being formed after the reactant. Just not to say whether I like it or not, hydronium has to be what? A conjugate acid. That's your point. Whether I like it or not, hydronium has to be a conjugate what? A conjugate acid. Here we go. And if you see very much properly, if I've got a conjugate acid here, this one has to be a conjugate base. Right? So that's a key for you. So this is a conjugate what? A conjugate base. Right? Now what else could happen here? What else going to happen here? We've got C5H5NH plus H2O here. We use Bronsted-Schroeder theory. An acid is a proton donor. A base is a proton acceptor. So what's going to happen here, If you see very much properly, C5H5 NH plus, it has given one hydrogen ion to water, which is H2O. Hence, water has been increased from 2 to 3, forming hydronium, which is a conjugate acid. You get a point, right? Which is a conjugate acid. Now, for it to donate an electron, and hydrogen here is increased, here to remain nothing here, which is here, right? Of which, that's what to say, it has given out an electron to water. Hence, this one occupy what? This one, for it to give out an electron, for it to donate an electron, for it to be an electron pair, for it to be a proton donor. This one, it will be a conjugate, it will be what? It will be an acid. I'm just abbreviating them, yeah, in terms of time. Then this one, if this one is an acid, this one has to be what? A base. It's more like a neutralization reaction that's taking place here. That's all for that reaction. Let's go to the next question. We've got hydrogen carbonate. If you see the hydrogen carbonate, here it is a reactant, there it was a product. So, reactant, you can only find the reactant only bases and acid, but not conjugate acid and conjugate base, no. So, hydrogen carbonate plus C5H5 NH plus, reacting with, producing hydrochloric acid, carboxylic acid plus C5H5N. Hydrogen carbonate reacting with C5H5 NH plus, producing carboxylic acid plus C5NH5, H5 and N. Right? So what's happening there? You have also to identify which one is a conjugate acid, which one is a conjugate base, which one is a base, which one is an acid. So see, that's question number 3. You have to be very much careful here. It's one and the same here, but you may ask your question. And it's a spontaneous or reversal reaction or equilibrium dynamic reaction. It won't be very much simple here as in other questions, because you do not have a product having hydronium here. So you have to use Bloch-Solar theory. So I've got four substances here or compounds. I've got carboxylic acid, hydrogen carbonate with a negative charge. I've got C5H5NHE plus. Also I've got carboxylic acid as a product. Please note that acid and bases they only find to the reactant. Then the conjugates you can find to the products, like so. And also I've got C5H5N. Okay. Here we are. I go ahead. So we use the Bloch-Solar theory here. Hydrogen carbonate, it has got a negative charge. Right? Here also you can use Arrhenius equation, something occupy negative, something occupy positive. One good for you. Different ways of identifying a conjugate acid and bases, but using theories. If you see something occupying a negative, that's a base. Something occupying a positive, that's a what? A conjugate acid. That's an acid. Right? So if you see very much properly, C5H5NH plus, it has given an electron to what? Hydrogen carbonate. Hence, hydrogen carbonate, it increase from the negative to positive. Negative, so negative, yeah, from negative to what? To positive. In fact, from neutral, to neutral. Because there, if I've got a negative here, simplify to say it's a negative 1 plus 1. Because if I've got negative there, that's simplify to say its charge there is negative 1. If I've got a plus there, its charge is plus, which is 1. So if you have to add the charges there, you may find to say it will give us 0, neutral. Negative 1 plus 1, that is 0. So, hydrogen carbonate, it will receive an hydrogen from C5H5NHH, of which it will increase its hydrogen. Right? It will receive its hydrogen. It will increase its hydrogen. From 1 to 2. As for it to receive an hydrogen, it is a base. Note that Bloss and last year defined a base to say it's a proton acceptor. So this one is a base. Be there. If this one is a base, this one is an acid. Yeah. If you find something to say this one is a base to the reactant, this one has to be an acid. So this one is a what? It's an acid. What has given out an electron. See what's going to happen here? We've got carboxylic acid here. Simple as that, carboxylic acid. You know to say this is a symbol for an acid. This is an acid. This is a chemical formula of an acid. So this one is a what? It's an acid. So hence, this one is a conjugate what? It's a conjugate acid. That's a conjugate acid. This one why? Because it has received an electron or hydrogen ion from C5H5NH+. Hence it has increased from 1 to 2 and having a neutral charge here. One for it to be received, that the one that it is occupying a negative, it's occupying this negative. After receiving, the one that is coming here, it's a positive 1. And here it's having negative 1. And if you add negative 1 plus 1, it is 0. Which is a what? Neutral here. Right? If this one is a conjugate acid, it is supposed to be a conjugate base. So I put what? CB. Thank you very much. Yeah, for identifying conjugate acid and conjugate bases, we end here. For identifying bases, conjugate acid, and conjugate bases, we end here. Yeah, don't forget to subscribe, like, and comment. See you in the next video.